A surprisingly small shape hides inside a lot of modern physics, the circle. Mathematicians call this symmetry group U1, written U of 1. It is the set of complex numbers whose length is exactly 1. Every point can be written as e to the I theta, which means cosine theta plus I sine theta. The key move is simple: multiply by e to the I theta, and you rotate. Nothing gets longer or shorter. Only the phase angle changes. So U1 is a circle of possible phases. Combining two moves just adds their angles. Turn by alpha, then by beta, and the result is turn by alpha plus beta. The identity is 0 degrees, and the inverse is turning back. Why should physics care about such a tiny group? Because waves have phase. A sine wave is not just tall or short, it also has a timing, like a clock hand showing where in the cycle it is. Quantum mechanics uses complex amplitudes, so it inherits this phase clock. If a whole quantum state is multiplied by e to the I theta, the measured probabilities stay the same, because the squared size does not change. But relative phase is different. When two paths or two components meet, their phases decide whether they reinforce or cancel. That is the engine behind interference. U1 also appears as the symmetry behind electromagnetism. A deep version of phase rotation is tied, through Noether's theorem, to conservation of electric charge. So the next time you see a complex exponential, do not read it as just notation. Read it as a perfect little phase wheel, one circle organizing waves, quantum amplitudes, and charge.